Hi, good morning, friends. This is KRISHNA, Department of Chemistry, DBS Engineering College, KAVALI. Today, I am going to discuss about another important models in atomic structure. Yesterday, we discussed about some problems. Today, I will also discuss about another important models. Now, look at here. The ionization energy of hydrogen atom is 1.312 into 10 power 6 joules per mole inverse. The energy of the required to excite the electron in the atom from N1 is equal to 1 to N2 is equal to 2 is. It means when an electron is always jumps from one orbital to another orbital, how much energy is needed? So now you look at here. The energy difference between the energy levels is delta E is equal to E2 minus E1. Here, the ionization energy means delta I E is equal to minus C1. So now the energy is calculated by using of the following formula. The ionization energy by N square. It means E2 is equal to ionization energy 1 minus 1.312 into 10 power 6 by N2 square minus of minus 1 3.12 into 10 power 6 by n1 square. Here the electron is always coming from n1 to n2. It means n1 is equal to 1 and n2 is equal to 2. Then you can substitute the n1 value in the following way. n2 is equal to 2. It means 2 square. n1 is equal to 1 square. So then you can calculate the finally you can get minus 3.39 into 10 power 6 by 4. It means 9.8 into 10 power 6 joules. So this is the energy is required when the electron is jumps from excited state. So this is the another important model, my friends. Again, we can explain the another important problem. Look at here. Which of the following species are isoelectronic species or isoelectronic nature? Before going to discuss about this one, what is meaning of isoelectronic? Isoelectron means a species which is having the same number of electrons. So look here, so they give the three options, A, B, C, D, A, B, C, D. Then D is nothing but all. Look here, the first one is nothing but N minus 3, O minus 2, F minus 1. The second one is nothing but neon, Na plus and magnesium plus 2. And then third one is nothing but argon, potassium, calcium ion. And the fourth one is D, all. So look here. The first one is nitrogen atomic number is 7. 7 minus 3 means 7 plus 3. Oxygen is equal to 8. 8 minus 2 means 8 plus 2. It is 10. And fluorine 9 plus 1 is equal to 10. So these molecules, each species is always having the same number of electrons, 10. Then look at here. Neon, Na plus, sodium plus, magnesium plus 2. The atomic number of sodium is 10. Sodium atomic number is 11, but it loses 1 electron. Then 10 minus 1 is equal to 11 minus 10 is equal to 11 minus 1 is equal to 10. And magnesium atomic number is 12. It loses 2 electron. It means 12 minus 2 is equal to 10. These species is also having the same number of electrons. Another important group, nothing but argon, potassium ion, calcium ion. Argon is atomic number is 18 and then potassium is 90. 19 minus 1 is equal to 18 and calcium plus 2 is equal to 20 minus 2 is equal to 18. And these elements is always having ions is always having the 18. It means in this problem, all the species is always having the same number of electrons. So that's why the option D is right. So again you can define the isoelectronic nature. Isoelectronic species means the species which is having the same number of electrons. So look here, the another important problem, nothing but the energy of the photon is the 300 electron volt. Then they find the wavelength. So like in this problem, they give E, energy is give, E is equal to 300 electron volts. But 1 electron volt is equal to 1.6 into 10 power minus 19 joules. So that's why 300 volts means 300 into 1.6 into 10 power minus 19 joules. Already we have the value of velocity. C is equal to 3 into 10 power 8 meter per second, and H is equal to Planck's constant. The value of the Planck's constant is 6.63 into 10 power minus 34 joules. So now we can calculate the wavelength of the electron. So E is equal to hc by lambda. But lambda is the wavelength. Lambda is equal to hc by E. So h is equal to Planck's constant 6.63 into 10 power minus 34, and c is equal to velocity 3 into 10 power 8, and then E is equal to energy of the electron is nothing but 300 volts, 300 into 1.6 into 10 power minus 19. Then you can get 41.4 angstrom units, or 4.14 into 10 power minus 19 meters. The meters 10 power minus 19 meters can be converted into angstrom unit. But 1 angstrom unit is equal to 10 power minus 10 meters. Look at this is the problem. Another important another important problem is the photoelectric work function of metal is 5 electron volts. Then find the threshold wave energy. Threshold wave energy is nothing but, look here, this is the work function. W is equal to pi naught is equal to 5 electron volts. It means 5 into 5 into 1.6 into 10 power minus 19 joules. So C is equal to already 3 into 10 power 8 meter per second. H is equal to 6.63 into 10 power minus 34 joules. Therefore, work function is equal to pi is equal to, or h nu naught is equal to hc by lambda. Now you can calculate the threshold wavelength, lambda naught, hc by w, or hc by pi. Then you can substitute the h value, and then c value, and then w value, or work function. Then you can calculate when you can calculate this composition. Finally, you can get 2.48 into 10 power minus 7 hertz. This is the way to calculate the threshold wavelength. So another important problem, look here on work function. The work function of a photoelectric material is 3.3 electron volts. What is the threshold energy of the electron? Same problem. Again you can calculate same one. W is equal to h nu naught. Nu naught is equal to W by h. Then W is equal to 3.3 electron volts. It means 3.3 into 1.6 into 10 power minus 19. And then H is equal to 6.6 into 10 power minus 34 hertz. Then we can calculate, we can get it 8 into 10 power 14 hertz. Look here. The another important problem is nothing but comparing the energies of two radiations. One with lambda is equal to 800 nanometers, and other one with 400 nanometers. So the energy of the radiation is calculated by using the following formula. E1 by E2 is equal to lambda 2 by lambda 1. Already energies is always given in the given problem. That is nothing but one is 400 nanometers, another one is 800 nanometers. So E2 is equal to, E1 is equal to 400 nanometers, E2 is equal to 800 nanometers. Then lambda is equal to radiations is equal to is always giving the lambda 2, lambda 1 is always given. Then E1 by E2 is equal to 1 by 2. That is equal to E2 is equal to 2E1. So this is the formula. Once again, you can explain the same problem. Comparing the energies of two radiations, one is with lambda is equal to 800 nanometers and other with 400 nanometers. Already they can give the lambda values, lambda 2 and the lambda 1. Lambda 1 is 400 nanometers, lambda 1 is equal to lambda 2 is equal to 400 nanometers, lambda 1 is equal to 800 nanometers. Then you can substitute in the given formula E2 is equal to 2E1. So another important problem, look here. Calculate the radius of Bohr's atom present in third orbit in lithium ion. So the lithium ion is always having the electron. That electron is always present in Bohr's third orbit. Then calculate the radius of the electron. So now look here. The nth radiation of the electron is calculated by using the following formula: n squared by z into 0.529 angstrom minutes. Now lithium n is equal to means the number of orbit. So already the electron present in third orbit, that is n is equal to 3, and then z is equal to atomic number, that is nothing but lithium, that is equal to 3. So then you can calculate the n is equal to 3 and z is equal to 3 in the given formula. Finally, you can get 1.587 angstrom minutes. So another important problem, look here. Which of the following ion is most stable? So generally, atoms or ion is always stable based on their electronic configuration. So when an element or ion is always having the completely filled electron, it is more stable. Or the ion or an element can having the half-filled electronic configuration, that element is also more stable. Look here, they give the 4 types of the ions. One is Fe plus, and then Fe plus 2, and then Fe plus 3, and then Fe plus 4. Fe means iron. The atomic number of the iron is 26.